Hi, my name is Nicole Rivera, and this is my application video for the Science Ambassador Scholarship.
Today I'm going to be talking about radiation, its uses and its effects on the human body. Radiation is the transmission of energy into the form of waves or particles through a medium. More specifically, these particles are photons, which are tiny packets of energy that can be bombarded into atoms. Radiation can travel in the form of sound, heat, and light. Radiation can be divided into two main categories: ionizing and non-ionizing. Ionizing radiation has a high frequency, meaning that it has several oscillations between a specific amount of time. Non-ionizing radiation, on the other hand, has a lower frequency. Ionizing radiation can be considered dangerous since the unstable atoms give off energy to reach a stable state, basically an atom with a tantrum. This can break chemical bonds, can even knock electrons off atoms, and can split neutrons and turn them into protons, which is called a transmutation. Non-ionizing radiation, on the other hand, is only harmful due to the amount of heat given off. An example of non-ionizing radiation can be found in microwaves, visible light, and even radio waves. A mixture of these two types of radiation can be seen in the form of UV light, which in times is non-ionizing but can cause effects similar to ionizing radiation. An example can be seen in the form of the sun's rays, which is harmful due to the amount of heat given off, but can also cause damage to chemical bonds in the human body, such as between the skin and the DNA. Radiation is measured on how often an atom will radioactively decay and give off photons of radiation from its nucleus. Usually it is measured using the SI unit called the becquerels, which is 1 decay per second. The non-SI unit is called the Curie, which is 37 trillion decays per second. The second one is named after Pierre and Marie Curie. Marie Curie was highly influential in the field of radiation and was an astonishing trailblazer in the field of women in science. While many schools wouldn't take in women to be educated, she sought out underground schools that would take her in and even taught herself. She coined the term radioactive. Marie Curie also worked with a lot of other elements that were known to be naturally radioactive, such as the case of uranium-92, thorium-90, and radium, which she discovered. Radium at the time was the cause of a lot of radiation poisoning due to the fact that when it decayed, the light produced by the bombardment of ionizing radiation gave what is called a radioluminescence, which meant that radium basically glowed in the dark. This was deemed to be very useful at the time and even was promoted to having health benefits. Due to its radioluminescence, it was used in face creams, eyeshadows, soaps, and even stores sold butter and milk laced with radium. Most famous of these radiation poisoning cases were the Radium Girls. Due to the radioluminescence given off, radium-infused paint was used to paint watch dials that were used in World War I. This was due to the fact that soldiers had to turn on lights to see what time it was and give off their position to the enemy. Using these radium-painted watches, they didn't have to turn on lights and could see the time in the dark. However, this was not as beneficial to female factory workers that were exposed to the harmful chemicals used in the paint. These women were led to believe that they would live healthier lives due to the amount of radium exposure that they would encounter in their jobs. They were even convinced to use their mouths to sharpen the brushes used to paint the watch dials. This would cause the women to ingest radium-laced paint that would cement in their jawbones and other parts of their bodies. The resultant of this was that many women suffered heavy tooth decay and even anemia. However, since the radium was often attached to the bones when ingested, a lot of them got what was called a radium jaw. The radium would give off energy and break the bonds in the bones, causing the natural cavities in them to grow larger and larger over time. This was as if they would have spontaneously gotten osteoporosis in their chins. This caused the public opinion of radiation to believe that it was a silent killer and dangerous in all of its form. However, it is not all bad. A type of ionizing radiation called X-rays, it is often used to take pictures of the bones through the skin. The amount of exposure is regulated and often represent no harm to the receiver and giver of the treatment. Radiation can also be used to treat certain types of cancer by exposing certain parts of the body to radioactive chemicals to destroy the specific cells that are harming the body. Radiation is also present in the form of nuclear power. Uranium atoms are split, and these give off radiation in the form of heat that heat up steam mills. Steam mills in turn generate mechanical energy, which is then turned into electricity. Radiation can also be used to sterilize medical equipment. And many times the use of microwaves can be used for sterilization. The non-ionizing radiation can destroy microorganisms in the surface of objects. Radiation also plays a part in radiocarbon dating, in which a radioactive isotope of carbon, carbon-13, is exposed to inorganic material and is used to determine the date in which the material was created. Even though radiation may be dangerous at times, by studying and conducting experiments on its uses and its effects, we can generate new inventions to improve upon our quality of life by using it. So as long as proper precautions are followed, radiation use can be completely safe to the general population.
Thank you for watching, and thank you for your consideration for the Science Ambassador Scholarship of 2017. Bye!